This is very likely the end of type 1 diabetes. Let me explain. My name is Devin, and I'm an anesthesia provider, but my daughter has type 1 diabetes, and it is all I read about. This company called Sana just released one of the most exciting trials I've ever seen in my life. On January 7th, they put this press release out that they were able to evade or hide insulin producing beta cells from the immune system. And they did it in Sweden with one patient. This study is being done in Sweden at Uppsala University Hospital. The patient, as you can see here, is a 42-year-old male. He was diagnosed with type 1 diabetes in 1987, and his A1C was at 10%. What they did is they took some human cadaveric islet cells that produce all of the hormones needed to control blood sugar, insulin, glucagon, somatostatin, and they modified these on a genetic level using CRISPR technology. And what they did was nothing short of a miracle. They basically played God. They made changes and edits to these beta cells that produce insulin so that the human immune system cannot recognize it. Because that's the huge problem with type 1 diabetes is your immune system attacks these cells and kills them. So they made these genetic modifications and they took these cells and they injected them into the patient's forearm muscle. The scientists at Sana were trying to figure out how long they were going to wait before they broke the news to the world of what they had just done. And they thought 2 weeks would be appropriate, but they doubled that and decided to wait 28 days. And here behind me, you can see what's called basal C-peptide. C-peptide is a byproduct of insulin as your body breaks it down. And when you check a C-peptide level, you're checking to see how much insulin is being produced by the body. You can see by day 7, this patient was producing a lot of insulin, whereas right before they were producing none. And you can see 14, day 21, and day 28 remained very consistent and even increased a little bit at the end there. This is what's called a mixed meal tolerance test. This is where they gave the patient some carbohydrates to see if those beta cells would rev up their production of insulin, and that's exactly what happened. This is what happens in a normal functioning pancreas. The level went from 10.5 to 17, almost doubled, which is incredibly awesome to see. Here you can see an MRI that they took of the patient's forearm showing proof that these grafts were still alive and functioning. Those arrows are pointing at the cells. When Sana was creating these cells that were supposed to evade or hide from the human immune system, they created 3 different groups of cells. Here you can see the 3 groups behind me. And they wanted to see which edits they were making on a DNA level were important to evading or hiding from the immune system. So they had 3 different groups. These 2 groups had partially edited cells, and this group had all of their edits. So they found out that it was very important to have all of their edits here. This is a screenshot of a video that they released. And when they hit play, you could see immediately the immune system started killing these cells. But over here, nothing happened. Nothing happened at all. I thought there was a glitch with the video, but no, it was playing. The immune system just wasn't doing anything to these cells. It was so awesome. One thing I want to mention real quickly is that Santa was not trying to cure this patient. They were just trying to establish proof of concept that these cells could evade the immune system. So they only gave this man about 5% of the dose of islet cells that a normal human would need to control their blood sugar. If they would have given him more of these cells, he very likely would have been cured completely. But that was not their goal in this study. It doesn't change anything on how exciting this is. So here you can see Sana's approach to treat type 1 diabetes. They make these hypoimmune or genetically modified cells that can hide from the immune system. That's step 1 over here. And then they need to figure out how to manufacture them at scale. And they're working on figuring that out right now. And then their plan and their hope is that they can deliver this therapy as a one-time dose intramuscularly to type 1 diabetic patients. I am making this video in May, and this news broke back in January. So we're at about 16 weeks past the point of this patient being dosed, and Sana actually released 12-week data, which I have a part 2 video on, so make sure you watch that. and it's very exciting. But behind me, I want to show you a mouse model that they did this same trial on, and you can see that after 64 weeks, they did not find any problems as far as cysts or tumors forming in this area. And you can see the mouse's blood sugar was very well controlled to the 64-week point. So it's very encouraging that no histological abnormalities in the tissue were taking place. No problems with these cells were being found, which is very exciting. So yes, this is only one patient, but I can't believe they were successful on the first try. This is incredible. So please follow along my TikTok channel here and follow along my Facebook page called Crushing T1, and I will update you every time Santa makes a press release. This is extremely exciting, and there's a few other companies with very exciting breakthroughs as well that I'll be talking about.